Hello, this video is about concentration, right? More specifically, molar concentration, right? I'll write molar here. Now, first of all, let's define it, right? So concentration, or molar concentration, is the amount of solute, right, in moles per unit volume of solvent. Now I'm taking everybody knows what a solute is, what a solvent is. Okay, just in case you don't, let's draw our attention to these two cubes here. And this first cube, some nice green particles. This first cube has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 particles in the box. Okay. This one has 1, 2, 3, 4, 5 particles in the box. Right? This one has a high concentration. This one has a low concentration. Now, the green particles represent the solute in this volume of solvent. So the solute is the thing that does the dissolving, right? So this is a solute particle. Right? The solvent takes up the remainder of the container. The volume made up by the cube. Right, now, what about the particular units we use? So if we write this as an equation, right, so we can write concentration equals amount of substance, right? So let's say number of moles of solute, divided by volume of solvent. Okay. Now the units we use are moles for the moles of solute, but we use decimeters cubed for the volume of solvent. This gives us a unit for concentration of moles per decimeter cubed. So what is a decimeter, I hear you ask? Now, 1 decimeter cubed, right, equals 1 litre. Okay? Right, why is that then? Huh? How does that work out? Well, there's a couple of quantities we should all be familiar with, right, when it comes to talking about volumes. Right, let me just leave that equation there. So we should all know that they're basically 1,000 centimeters cubed, right, in 1 litre. I think we're all familiar with that. Yeah? Okay, so we can say basically that 1,000 centimeters cubed equals 1,000 milliliters. Agreed? Yeah? So that must mean that 1 centimeter cubed equals 1 milliliter. Right, I'm glad we got that straightened up. So what we're saying is that if we've got if we've got a meter cubed, now that gives us a ton. Hold up, I'm just going to end up confusing you online. I don't want that. Oops. Right, so I'm glad we straightened that out. Right, so now, what's a decimeter cubed? So a decimeter, 1 decimeter equals 10 centimeters. Okay, now if I draw a box like this, right, okay, and I'm going to write, okay, so 1 decimeter times 1 decimeter times 1 decimeter, that gives me a decimeter cubed, right? So the length times the breadth times height gives me 1 decimeter cubed, but it's the same as saying 10 centimeters by 10 centimeters by 10 centimeters. I do believe that 10 times 10 times 10 equals 1,000 centimeters cubed. And we're saying that that equals 1 decimeter cubed. See? So 1 decimeter cubed equals 1 liter. So basically decimeters cubed equals liters. Yeah? So there's our equation. Concentration equals number of moles of solute, volume of solute. Now if we write that in shorthand, let's stick that in a triangle for you. Okay, stick that like this. So we can say concentration equals number of moles over volume. C equals N over V. If we'd like to put that in a triangle. So that's concentration, volume, here. Right, so okay, there it is in the triangle. Wonderful, very good. So now what? So you know that you're going to have to be able to use all of these things in the equation. So you know, C concentration, moles, and concentration in mole per decimeter cubed. Excuse me. Number of moles. Solute, which is in mole, and V equals volume in decimeters cubed. So, what's this telling us? Well, let's say we had a beaker. In that beaker, let's say we had 250 centimeters cubed, right, of a 0.5 mole per decimeter cubed solution of sodium chloride. Right? Now, how many moles? Okay, so how many moles of sodium chloride do I have in here? So calculate the number of moles of sodium chloride in the beaker. Okay, well, I think simple. Let me look at that equation again. Right, so if I rearrange it, I'll say number of moles equals concentration times volume. So do I have the concentration? Yes, 0.5. Okay, so concentration is here. This is my concentration. Right, so okay, we'll write 0.5 decimeter cubed. Right, times the volume. Right, here's my volume, but that's in centimeters cubed. I need it in decimeters cubed. So I turn that to 0.25 decimeter cubed. Okay, so this gives me 0.125 moles. Right, so I've got 0.125 moles. Now you could be asked to work out the mass of that sodium chloride if you were to evaporate it off, the mass you could get from that number of moles of sodium chloride in there. There's a simple example of using the concentration equation. Of course, you could be asked to calculate the concentration of something. So what about, let's say you were asked a simple question like this. So alright, so let's say you need to dissolve 180 grams. So imagine you ask a question like this. So you have 100 grams of glucose, right? 100 grams of glucose dissolved in 1 liter, right? So, and it asks you to calculate the molar concentration. Wonderful. So So what do we need to know? Right, so first up we need to know the volume. Right, now the volume is 1 liter, which is 1 decimeter cube. Wonderful, we've got volume. Now what are we also given? We're given a mass. Given a mass which is 100 grams. Right, and what we need to find in order to calculate concentration, let's look at my triangle again. Concentration is number of moles divided by volume. So I've got volume and I need the number of moles. So how am I going to work out the number of moles from the mass? So we must turn our minds back to the other relationship, which is relative formula mass equals the mass divided by the number of moles. Yeah. Okay, so in order to find that number of moles, I've got to divide the mass I have by the relative formula mass of glucose. Okay, now the relative formula mass of glucose, right, which you should know how to do it. Okay, glucose is C6H12O6. In fact, you can do that in your own time. MR of glucose, okay, is 180 grams per mole. Okay, if you don't know how to do that, go back to the other video. Now, in order to work out number of moles, then we divide M by MR, like we said over there. So that's 100 grams divided by 180 grams. And let me just plug that into my calculator. Excuse me 1 second. Should have it ready. 100 divided by 180 gives me 0.56 moles. Right, so I've got 0.56 moles. Okay, I know the volume is 1 liter, so the concentration equals the number of moles divided by the volume. So we had 0.56 divided by 1. So 0.56 moles divided by 1 decimeter cubed gives me 1 mole per decimeter cubed. Now there's your answer, 1 mole per decimeter cubed. However, I should also tell you that you might sometimes see a capital M, like this. Now it's the same thing. You see a capital M, this is the same as moles per decimeter cubed. Okay, so the molarity, this is known as, sometimes you hear it called concentration molarity. Oops, shifted that all over the place. Anyway, thank you for watching.